Okay, for our next tutorial we're going to be showing how to get like a parts list for our components, but also to identify all the individual parts of our circuits. As we see here, I've got a pro streaming setup with not one but two cameras. This one over here is just set at a very low focus, so I can zoom in on individual parts. Bit of a spoiler, we have our screen over here at the top showing the resistor chart, which we're going to use to find out our resistor values, and then we're going to see what we can do when we get components that don't match their resistor charts. And over here in the bottom corner of the screen, I have a notepad set up, which I'm going to start to do my um, parts list, my Stocktake. You should probably use something like Word or Excel or Google Docs or something that has a table format. I've just found it difficult to load the table format up on my stream, so I'm just going to put it up on Notepad, but for your tasks, use whichever sort of table you want to, because it means you can add in a picture, which I'm going to be unable to do here, but it's on stream so you can see individual parts. So this over here is the parts components. If we zoom in, we have a bunch of characters there that, well, I personally don't know how to understand, but we see here it has 12 LED. So we know that the part over here involves 12 LEDs. It's from AliExpress. We open it up. I'm just going to put all the components onto the floor here. So inside here, we can already start to see some of the components we have. The first thing we have here is a circuit board. If I zoom into the camera here, we see one part of the circuit board over here. We have all individual notifications. So for example, there where we see R3, that's going to relate to like our resistor. And we already start to see some values there like 10K or 10K. And we go through the board. On the other side of the circuit board, we have over here, we have all these metal contacts. Let me just get a high-tech pointing implement over here. Over here we see we have these exposed areas of the circuit board, which are these metal tabs over here. When we solder, we're going to be able to solder to those metal parts. So then we have these other areas over here that are greens, different shades of greens, which there is copper underneath there providing connections on that area from the circuit board, but they're covered up by a layer of lacquer. Now if we put enough heat on this with a soldering iron or like a heat gun or fire, or if the circuit itself overheats due to like creating a short circuit, that lacquer itself can melt and it can cause other short circuits in our system. If we look at an example over here between like this square and let me zoom it in. An example between this square and this square, we see how there is a line connecting. Oh, there is a line connecting this to this. Right, with that light green line, that means that if we were to remove the lacquer, that would be a solid copper trace between those two dots. So they're like equivalent to soldering a wire connecting those two areas together. So if we zoom out, I'm going to put this one on the top camera. If we zoom out, we can see that we have our entire circuit board. So in theory, we can, when we have some sort of issue with like a soldering problem, or if a circuit board is to break in some area, we can use our knowledge of what the circuit board looks like to resolder joints and to fix them up. And I'm sure you've already done that in several classes. And here is a view of the entire circuit board. Let me give you that focus. There is an image of the top of the circuit board showing all the individual components. Over here we have everything from where the voltage goes in. All these L's are all for lamps, so they're LED lights, and then we have resistors and capacitors. So we know we're going to use these in our circuit. So first thing I'm going to do here in my notepad is I'm going to start to write down what my individual parts are. So this part I'm going to say here is a circuit board. Circuit board. Let me just neaten this up a bit. Okay, circuit board. Quantity of the circuit board, we have one of them. Values. It's hard to explain what we have here, but it looks like we have a single layer circuit board. So it means there's only copper's only connected on one side. The other side doesn't have any copper on it. More complicated circuit boards can have multiple layers, can be in both double-sided, but you can also get like individual layers of circuit boards together. For example, a computer motherboard which is one of the more complicated circuit boards that you can deal with, has like 7 layers potentially. So you have different copper, and so it allows you to have much more complicated connection wires between them. Alright, so let's move on to some other parts. I'm just going to lay these around. Where do we want this? Over here. Looks nice. Great. Okay, so the next part, I am going to just rummage through my parts here and look at my components. So next over here we have, I'm just going to get these are the LED lights. If we zoom in on the camera here, we have our LED lights. Let me just get all those over here. 1, 2, 3, 4, 5, 6, 7, 8. Alright. So we have our LED lights. If we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 LED lights. So we already see here that our diagram over here is saying 12 LED lights. Well, that is referring to the amount of LED lights that were used on the circuit. Right, on the circuit we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 LED lights on here. It's often cheaper for the company just to produce an extra, to give you spare LED lights, so it means I don't have to have the 100% manufacturing quality. It's cheaper for them to just send you extra lights, so nobody asks for a refund, because to actually physically send another light to you by mail is far more expensive than them just giving you a couple extra lights. Which is good. So as you get multiple sets, you'll eventually have like random LED lights that you can use for stuff. This is all great. So let's look at the LED light. As we go up over here, we see that the LED light itself has 2 different leg sizes. Right? And when I look at it on this side camera over here, we see the LED light has, where are we? If we see this area of the light over here, where I'm pointing my pen at, see how it's flat? This side of there's like some sort of cut over here, how it's flat compared to the other side, which is smooth. So the flat side of the LED light, as you see by my diagram over here, the flat side of the LED light actually relates to the short leg. And so we know that an LED light is, so LEDs are, they're polarized. They only work if the current's flowing in one direction. So they have to show some sort of indication on the actual LED light itself to do this. So what they do is, when you have your component, the long leg is related to, the long leg itself is related to the positive. But the issue we have is, once you solder it onto a circuit and you're going to cut down the size of your legs, you're not going to tell where the longer leg was. So they also make it so the flat side of the LED light is related to the negative. And this is also going to be important for when we look at our diagram. Let's do the zoom in. When we look at our diagram over here, we see an example of, let's rotate that. Over here, so we have L7, which is going to be like LED number 7, and we see how that circle, where are we? Over here. This circle over here is not a complete circle. It also has that line over there, so we can match that up with our LED light when we put it in there. So for example, when we put our LED light in here into the circuit, we can see how we're going to match up that flat area. We can match up that flat area to match, so the LED, we know that it's in the right direction, because otherwise it's hard for us to tell which is the positive and negative. So we have 12 LED lights. Let's add this to our parts list. So we have LEDs. The number of those, we have 15 in our kit, but we only need 12. So actually, let's write, we need 12 in our kit, but let's say we have 15. So we know this. Information about our LED light. We don't know the color of it yet. Once we set up our circuit, we'll find out the color to find a replacement LED light. I have a small ruler over here on my table, and it says that it's 5 millimeters. So let's just do a 5 millimeter LED. Based on the circuit, I'm guessing that it's low voltage because this circuit is between 2 and 12 volts, but we don't know the exact voltage of it yet. So all we know so far is it's a 5mm LED, and so we can replace it if we have to, especially when we come to more complicated circuits, and we're going to have to do that. So let's put these LED lights over here to the side. Next, we will deal with, let's do the capacitors. So these over here, we have 3 capacitors in our circuit. Let's zoom up on the camera. So the capacitor, we have over there, we have 47, let's get that focus, oh there we go, 47 UF 25 volts. So first thing we know, and the actual look of the capacitor is an electrolytic capacitor, and it has a similar thing to the LED light in that the legs are different size. If we zoom it over here again, up to the camera, the legs themselves, come on, focus. The legs themselves are different lengths. So, and if we look over, if we rotate it, we should see that there's also a sign for a negative is on the shorter leg. So just like the LED light, the shorter leg relates to the negative, and this one, instead of, because the capacitor doesn't have a cut on it like the LED light, they have to show it with an image, so they actually print out where the negative line is. And when we put that on our circuit diagram, if we look at the small camera over here, if we look at our circuits, we see that we have some sort of white marking over here to the side. So that white marking is going to relate to the white marking on our capacitors. So we can put in our, when we're going to solder in our circuits for our capacitors, we're going to have them in this way. And then we'll push that in and we can do that. So we know that's a capacitor is good. All right, so let's add this to our Stocktake as well. We know this is a capacitor. So we can already put our type of capacitor. It's an electrolytic capacitor. Let me just get the right spelling for that. Okay, so we know it's an electrolytic capacitor. It's a big word, so just to fit on my thing, we know that's short for cap. As I said, when you have your table and you have your formatting, it should be easier for you to draw this thing down. Alright, so we have 3 of those. And values, well, we know that our values we had, let's look at our thing again. Our values are 47 UF and 25 volts. So when it comes to our capacitors, these are things that often get replaced because they have a lot, depending on how much load is going through them. When it comes to replacing capacitors, the most important part for the functionality of your circuit is making sure you get the right capacitance value, which is the microfarads, which is the F. The actual voltage just means if you're dealing with a voltage higher than the voltage that these things are set for, it could cause short circuits in it. So it's only rated at a certain voltage. So if we want to replace that with a 47 microfarads 60 volt capacitor, we can do that because it just means our circuit, as long as we're not going over 60 volts, it's perfectly fine. And we know our individual circuit here is rated between 2 and 12 volts is what's recommended. So our 25 volt limiting capacitor is fine. Just so when we have to replace it, like in the workshop, sometimes we only have like 60 volt capacitors, and they tend to be larger because they need like more space to stop the voltage from short circuiting. Next, we have these 3 components. These 3 components are, well, they're transistors because they have. Let me hold one up here. So these individual components over here are transistors. They also have a crescent shape looking thing, like a similar, almost like our LEDs. That is also going to relate to when we put it into the circuit, the individual shape that we use for them. This is where the this part over here with its 3 dots. As we see here, we have a line as well, so we can line that up. So let's look at the information now. Bear with me for this. I'm going to show this up onto the micro screen here so you can see it. We might need to get some, let me see if I can gain us some light on this. We might have to wait for a bit of a reflection for this to work. Okay, there we go. So we see there we have S9013. So I'll put this one over here. The next one we have is S8050. I'm going to put that one in a different spot over there. And we'll look at the last one. We have S9013. So we see here we don't have all three of the same capacitors. We have one of the 8050. So because they're actually difficult to see, because I have to like zoom in, and especially if you have like visual assistance, if you need that, it could be difficult. So what I like to do is I'm actually going to put a label on the 8050 component, so I will know definitely where that what that component is. So that's over here. So let's write those components down onto our chart over here. So we have S9013. Actually, no, it's a transistor. And its value is S9013. And we have one of the S8050. Good. All right. So another component that doesn't need much talking about is just this little piece over here. This is just a connector that when we're going to solder this into like this part over here at the top, just so we can have just so we can connect some power to our system. We can write down that it's just a connector plugs. One, and it doesn't have any information for it. All right, so now we have the tricky part. We have over here, we have resistors. So I'm actually going to move the camera for this one so we can look in here. So over here we have a variety of resistors. We have 6 in total. Let me line those up. All right, so over here we have 6 resistors. All right, now if we look at our circuit, and we see our circuit over here, we have 10Ks and 10Ks and 470. And our total resistors are 1, 2, 3, 4, 5. We have 6 resistors in total, which makes sense in our circuit. Now we also know our circuit is divided up into 3 10K resistors and 3 10K resistors and 3 470 resistors. So when we look at our resistors, we already know that there's color bandings on them, so I'm just going to group them. I'm grouping the 3 with purple, and I'm grouping the 3 without purple, or the 3 with orange. So let me set this down over here again. All right, so this resistor over here, let's look at this one. Let's zoom in on this one over here. So we have a resistor there. Is that a good example? Yes. All right, so we have this resistor over here. It is we're going to use this table, which is up over here, to find out what size of resistor this is. So the first thing we notice, the actual background of the resistor is cream. So that actually does relate to the type of resistor we're dealing with. A cream resistor is a 4-band code resistor, as opposed to like a blue one, as you see in the bottom of that picture we have in the top of the screen, is a 5 band code resistor, and there's I think there's green is for 6, but I'm not completely sure on that one. So it means when we're looking at this resistor, we should be finding 4 bands. If we look at the chart for 4 bands, we see that the first band relates to the first digit of the resistor. The second band relates to the second digit. The third band is a multiplier, so we're going to times the third band by the first 2, and then the last one is going to be the tolerance. So with our resistor, and the most common question I get from students is, where do we start with our resistor? Like, which one is the left or right? Well, the thing is with resistors, typically, if we look at our resistor chart, we see that gold and silver, there is no value for gold and silver that can be on the first resistor, on the first band, because it goes up to white is 9, gold and silver are no values. But gold and silver are the most common tolerances when it comes to resistors because it's the cheapest type of resistor. When you're dealing with more advanced resistors, you might need to do some sort of additional testing, especially if it's confusing if they're using like a brown a 1% tolerance. So, but if we look at this resistor, if we start rotating this, we see here we have some. There we go. Okay. So you see there we have some gold on the resistor right over here. Right. So this over here is going to be the gold band. So it means we're reading the resistor from this side. Right. So this is going to be our band 1, our black is our band 2, and then our orange is our band 3, or our multiplier band, sorry, and then our tolerance is over here, the gold. These are not the most expensive resistors, as you can tell by the kit being from a country that's known for making very affordable electronic components. And even though the resistor itself will function perfectly fine for the needs that we have, the quality of the paint on it was not the best, and as we can see there, the gold paint is clearly the one that's rubbed off first when touching other components in the box. So if I actually rotate this, around, we can see that the gold paint is like clearly rubbed off in some sections. So it's going to take some investigative work to actually find out where. So that's clearly the gold there. It's going to take some investigative work to find out what the actual banding of some of these resistors are. But let's do that maths here. Okay, so brown is 1. Black is 0, so we have 1, 0, that is 10. Then we have orange. Orange is the 1k kilo ohm multiplier, so 10 times 1 kilo ohm, so that's 10 kilo ohms. And the gold means it's a plus or minus 5%. So this makes sense. We know this is our 10 kilo ohm resistors, as our circuit diagram has showed us. We have 3 of those, so let's add that down before we forget. So we have resistors. We have 3 and 10 kilo. I don't have the ability to do omega, so I'm just going to write the R to represent the K, so to represent the ohms on my system, but we also know that it is plus or minus 5%. So let's find out what we actually mean by that, because now's a good time. So over here, I just have a voltmeter. I mean, it looks complicated, but because that's just I bought it off like eBay, and it's a general multi-purpose one. But for our task itself, it shouldn't actually. For our particular task we're doing here, it shouldn't matter. Let me just get these around from the wires so you can see the display of this screen. Right. And we don't need lights for this part because this screen is it is lit by a backlight. So let's plug up one of these resistors and then see what happens. So as you can see on the main screen, all I'm doing here is getting the resistor, plugging it into the 2 of these alligator clips. Alright, so it's plugged in over there. Then I press my button to testing. Let me get that focus for you. Alright, so here we see this resistor over here. This is a 10.30 kilo ohm. So you see it's not exactly 10. So that 0.3 is that part of that plus or minus 5%. It just means, well, we know our resistance value is based off a lot of factors. The material itself has its own resistance, but its cross-sectional area, even the temperature can change. And so it's cheaper to make a resistor with a lower resistance. And the other resistance will change their value with that as well. I'll fix my focus later. So I have 3 resistors. Now, again, to assist me so I don't make any mistakes later, I'm going to write the values of these. These over here are the 10 10K resistors. And I'll put those over there. So now we have these ones. I have to adjust the focus on my camera because that's not that bad actually. So these over here, these are the worst ones in the fact I've looked at the kits, and these are possibly some of the worst resistors that I've seen coming out of the country of origin where these components are very affordable. We see here the actual resistance value. I'm not going to say the actual performance of this will be perfectly fine. There's nothing wrong with the performance value of this. It's just the actual print job on them is causing some issues. And it's interesting, like different paints use different pigments and their actual ability to attach the stuff is different. So we see here clearly that the purple paint is a better quality paint than the other ones when it comes to sticking to the appliance, the coatings. Over here we see that thing is again, and the last one. So what this means is we need to use some sort of investigation to find out what the values of these resistors are. So we can either find a circuit diagram for our circuit and then find out, based on the resistors we know, we have 10K resistors, but we don't know exactly what these ones are. We know that our circuit diagram requires us to have 10K and 470K. 10K and 470K resistors, so we can already guess that this is going to be 470. And then we can also double check that where we see, we know that the second band is purple, so we know that's already our 7 value, and then our next one is our brown, so it's going to be something purple times 10. So it's probably going to be 447 times 10 is going to give us these values to be 470. Depending on how complicated the circuit is, we can find that out. We can also use our voltmeter, so I'm going to plug up my voltmeter again. Maybe the voltmeter might be easier to do it this way so you can see it up on the screen. So let's plug up our circuit again. So there we go, 472.1. So there we go, that's in between our 5% again. I saw specks of gold on it, so it does look like a 5% resistor. So I can confirm this. Now we can use any sort of voltmeter that has a resistance checking capacity. It's a fairly standard feature, and that's like something else we'd use in the workshop. So again, especially for these ones, like if we have a large group of resistors, like if these fall into a bucket or something with other resistors, it's going to be very difficult for me to remember where they belong, especially if I don't know if they're in conjunction with this particular circuit over here, or if I'm giving this when I'm building it. So again, I'm going to write down my sheet here, and I'll write 470. 470 ohms. So with that looks like we have everything in our circuit that we need. I have to write it down onto the sheet. So the last part over here we have our resistor, and we have 3 of those, and this is 470 R, and again we have plus or minus 5%. So That's all my components now. I can, again, if you're doing it in your report, you're going to add in a picture of them to make it look better. I just could only put this onto the sheet here. So I'm now ready to start doing my soldering, and that's what our next tutorial will be. All right.